Welcome friends, this is the video from week 4 in International FDP on environment and sustainability on the topic melting of metal using furnace. I am presenting to you from Sanjay Godavat University. My name is Ingres Sanjay Kumar Mahadev. In week 1 video, we have studied about the evolution of manufacturing system and how it changed itself from traditional manufacturing to lean manufacturing, from lean manufacturing to green manufacturing, and now it is the time when we are talking about sustainable manufacturing. We discussed about the 6R approach and different stages in the life cycle and how to apply the concept of sustainability in these stages. Also, we studied about the sustainable value creation factors and the strategies and the drivers for sustainability manufacturing system. In week 2, we taken a case study of a foundry and we studied about energy required for melting of cast iron in induction furnace. And we found that almost 70% of the total energy is used in this melting section. And then we decided to focus on reducing the energy required for melting. We studied what are the sustainable practices which helps us in reducing the energy required for the melting, which helps us in reduction of CO2 emission. Now when we go through this video, okay, you will study about the in week 1 video, that is evolution of manufacturing system from traditional to sustainable. It is a second level, that is understanding level in Bloom's taxonomy. Then we studied about the how to prepare the strategies and drivers for sustainability manufacturing system. So this is the third level, that is apply in Bloom's taxonomy. And what we are going to study is the what are the steps to recommend to reduce the CO2 emission for melting of cast iron, and this is the evaluation level, that is fifth level in Bloom's taxonomy. So this number represents the Bloom's level. The explanation is given here. We have used some of the standards for calculation of CO2 emission and planning of the activities. In week 1, we refer to the ISO 15001-2018, which talks about Plan, Do, Check, Act, that is PDCA cycle for continual improvement, which incorporates energy management into everyday organizational practices. Okay. Then we discuss about ISO 14001-2015, which talks about energy use and the management. Okay, in week 1, the related topic was drivers and sustainability. The same two standards are also referred in week 2 to decide what are the practices which makes it sustainable and energy required for various sections in foundry. Okay, now in this week 4 video, we are also going to use ISO 17742 2015 for energy efficiency and saving calculation. What we have done is we have taken one case study in a foundry and we measured the energy consumption level before implementation of the practices. Then we recommended these 3 standard practices: charging below coil level, reduction in antenna height, and using the furnace cover. And after implementing all these 3 sustainable practices, again we measured what are the units consumed per kg of metal. Actually the furnace is of 150 kg, but for this calculation we have converted into 1 kg and the graph has been drawn. And we found that after implementing all this, the energy required has reduced and it has helped us in reducing in the CO2 emission as well. We have calculated the carbon emission competition before implementation. We know that from the standards we got that CO2 emissions due to electricity generation is 0.82 kg per unit. Yeah, electricity unit is kilowatt hour. So in selected foundry unit, we have measured average energy consumption for 100 kg of cast iron. It comes out as 74.14 kilowatt hour. And so we calculated the CO2 emission in kg for this 100 kg of cast iron, which is equal to 60.7948 kg. We have assumed for the simplicity, in order to calculate what is the annual benefit, that there are 12 months in a year, there are 25 working days per month, and there are 12 melting cycles per day, because each melting cycle is of 1 hour and the company operates in 2 shifts. So 12 melting cycles are easily possible, and in these 12 melting cycles we observe that 218.86 tons of CO2 emission was there per year. Then we measured this after implementation. This CO2 emission due to electricity remains the same, 0.82 kg per unit. Here kilowatt hour is the unit of electricity, and then we calculated for per melting cycle the average energy is now reduced to 64, and therefore the CO2 emission in kg for melting of 100 kg of cast iron, it comes out as 53.177. We continued with the same assumptions, and with the same assumption we calculated that CO2 emissions in tons per annum is 191.4372. Then we calculated the sustainability competition based on the net saving in CO2 emission. So we studied before implementation it was 218.86 tons, and after implementation it is 191.4372 tons. So there is net saving of 27.424 tons of in CO2 emission. Some of the parameters that we have observed in the case study, that it was a coalesced induction furnace, capacity was 150 kg, there was only one furnace, melting cycle time is 1 hour on an average, the number of melting cycles are 12 in a day, the mold preparation is 20 molds were prepared per hour, there were 26 workers, and each shift was of 8 hours, and the company operates in 2 shifts. We implemented these 3 practices. Now what we'll study, what is the effect of each practice when implemented. So here you will find the charging below coil level. It is this is the graph for the units consumed per kg. Again I repeat, the furnace is of 150 kg, but for the comparison purpose we have converted and calculated what is the energy consumption per kg in units. Then we implemented the second practice of reduction in antenna height, and there also we will find, yes, the energy required per kg also goes on decreasing. There are some abnormal peaks due to some unavoidable reasons, and those are to be avoided while calculating. Now again we will find, when we recommended to make use of the furnace cover, again the energy, this is a graph of energy consumed per kg, and what we'll find is, here we have done the comparison, what we have shown here, the existing conditions, and then what is the impact of each recommended practice on the total energy consumption. Okay, this was in support with the claim that we have made in the first few slides. Thank you very much for watching this video. Now it is everybody's role, okay, to make the processes which are environment friendly and sustainable. Thank you very much.